Great. Hongmin, you've got the first item on the list. And you're on mute.
Okay, we'll share my screen. Okay, I have just one item today, which is to guide everyone through the epic I'm working on. So this is big. In this epic, we are investigating the possibility of shading very psychic, and there are some items I'm working on. And the first one is to understand which components are interacting with very psychic. And it is in this item, I really want to understand which components are in our system and how they interact with very psychic, and understand the key by the accept pattern and other characteristic of each component. And then we will verify this key pattern with the traffic analyzed from the Russian really psychic. And then we need to defer proper model to keep the components functioning as they are, and how the model can help us scale the horn rate system. And then we need to benchmark each model against different rate setting using the Russian traffic. And finally, we implement a proof concept that support pushing job and fetching job from multiple rate instances. And finally, we evaluate the readiness and the operability of the solution. And I'm recently at the first item, which is to rate a curated list of interaction with Redis psychic. And in this issue, it simply just go through on the item and on the components we had in the in our system, in the Rails code base, and on the application we have. And this is on everything I found. I'm not sure whether this list is completed or not, but I'm quite confident that I scanned through on the each line of support in our Rails code base. And I'm still not very sure, but we can verify that later. So from the list of components, I go through all of them and then analyze how they can interact with Redis psychic, including the command they issue, the key pattern, and any action they perform. And there's a massive list of components, and have to go through each of them and actually run it in my console, and then capture the command in Redis. And finally, I composed this map, and this map is massive. It is hopefully it is enough. And you can see I draw the Redis psychic on the map, the Redis server, and each component we have, and the interactions between them. So from the map, it is we can understand how they interact with Redis psychic, which keys by on the component depend on, and with what keys by is the hotspot we need to care about. For example, the schedule and retry are the most popular keys that other components are interacting with. So when we design a model in later step, we really need to look at the schedule and retry. And then some components just work a lot with of the keys, such as the GitLab Exporter. This one was with merely on the keys in Redis psychic, and we really want to cut it down and how to maybe we need to rewrite it in later step. So there's more. And after we have this, we can continue to the next one, which is to design a model for scaling psychic. So this is just a verification step. We used to have different models for each one, and we need to redraw the map for the model. For example, I create 3 models. The first one is to functionally shade the Redis psychic, but on the Redis instance, there's nothing in between. I'm still working on that. The second one is that still functionally shade the Redis psychic, and we have 2 type of instances. The first one is the per queue instance and the common Redis instance. And this model works quite well. And for each one, I have to redraw the map and try to map all the components and in the interactions to that model. And in this model, it's quite a little bit complicated, but actually it works quite well. And yeah, I won't go into the details, so I put the link for everyone to read the map later. And for each model, I will need to find what is the solution for this and what is the key thing we need to do. And then I try to go through the component matrix again and try to input the solution for each component to see whether it matches what we want to achieve and how well, and the overall effort we need to put in. And we will do the same with other like the journal scikit cluster. Although we already have a really huge epic for this initiative, but we need to go through all of them again and map into the map to see what we need to do in the future. So after this step, when we have different models for us to compare, then we can continue to the benchmarking. And the benchmark, we can use the cases for benchmarking, like what we already did with the this one. So we need to capture the traffic on direction cluster of Redis Scikit, and then we try to simulate the traffic against different scikit testing. And because we already have a map, a really massive map for and how the component interact, we can just simply create a set of scenarios that match each model and with the key pattern of each model generated. So I think the load test is really realistic and it can reflect the traffic we want to achieve in the future. So that after the load test, we can understand how much headroom we have in the future. And then for each model, we can understand how it can help us scale and what is the limitation of each one. So yep, and finally, we implement some room concept to prove that that solution is workable. And then finally, we evaluate the observability and the administration of that model. So that is the approach I just at the first two items. So yeah, that's it for my turn. Any question?
That is an amazing amount of work that has gone into generating those maps.
Yeah, thank you. It's that actually took a lot of time last week for me to put everything on the map.
Did you, when you're doing that, see any parts, especially in the GitLab code base, that are using Sidekick Redis that shouldn't? Like, for example, the duplicate jobs could get away with not using Sidekick Redis. I just thought it was like appropriate at the time.
Yes, okay. There are some of them we need to look at. The first one is the batch pub queuing. So I don't understand the reason behind that, but it should stay in the share state, not in the Redis Scikit. We can push it that out. And the second one is the GitLab Scikit status. We can push that into share state because whatever we do, we still need it to be global. And this is like a locking state, not the one that belongs to Redis Scikit. We can push that into another instance. And yeah, when doing that, one interesting thing I explore is that a lot of things interact with Scikit APIs. So when we move to other model and when we shade, we can easily batch or not batch, but create like a federation system for the Scikit API. So that all the UI still work and all the components still work. And yeah, we don't need like to put a lot of effort into batching on our components. So yeah, that's one good thing.
Looking at this picture, I'm surprised at all the things that are not Scikit client or Scikit APIs that talk to Redis, and I wonder if it would be worthwhile to just get rid of all those things. So take the global ones, move them to a different Redis, and take the things that do need to talk to Redis and only have them talk to either the Scikit client or the Scikit APIs. Because some of, like Mailroom, the fact that Mailroom does not use the Scikit API is a weird legacy hack, because we used to write code where we just directly push some JSON onto a Redis key to enqueue a Scikit job, which is
about that. We discussed about the Mailroom in like once per 2 months or something, and we actually have an initiative for that. Where is it? Okay, this one. So we trying to migrate on pushing directly into Redis to use the webhook system, but when I look at the proposal, it's just a massive effort, and I'm not sure whether we should touch this one before this scaling Scikit thing or after that. It just took a lot of effort, and it's truly a technical depth, but I'm not sure.
When we say it's a lot of effort, are we talking weeks, months? How much is a lot of effort?
Well, maybe it should take at least 1 month. Yeah, that component is quite small, but the configuration is really complicated. We have omnibus configuration, and we have like a Kubernetes chart for that, and we have to update the configuration and make sure that it is backward compatible with the previous one. So it's
but that's kind of normal if you want to change these things. I'm not sure that is necessarily super
it sounds
super complicated.
The thing is, like, we've done this before, so it's like more known stuff to do.
Yeah,
it's not a it's a known problem how to solve, and it makes the system cleaner. And then whatever we do with scaling Sidekiq will be easier if we don't have to accommodate these things that use Sidekiq in a unofficial or weird way.
yeah, agree. So maybe this one should be in the dependency of the Sidekiq epic we are working on.
Well, I think we can compare the work that we would need to do, but I think like this is like known. So if there's an idea to do mailroom the other way, like make mailroom talk to the separate site, separate Redis instance directly, and yeah, that's also going to require configuration and whatnot. So like, yeah,
and like what would we rather have? Like a mailroom be a special thing that talks to Sidekiq, or mailroom be something that makes internal API calls? I think that anything that uses internal API calls is going to be simpler, and then in the future we don't have to think about it anymore. It's just a thing that calls the internal API. So
yeah,
right, we have to spend time dealing with mailroom one way or the other, so we might as well deal with it in a way where we don't have to think about it again in the future.
Yeah, agree. So maybe we should spend some time for the mailroom. And the good thing is that it should run in parallel with the this epic, because this epic is still at the really first early stage, and we can still like do the mailroom first, and and parallel works. So it won't block the epic.
And I also wonder about these shared state things that we can already start cleaning those up. And that would take pressure off of the Redis Sidekiq server. It would be easier to reason about the workload if there isn't non-Sidekiq random stuff also happening on the Redis server. And for whatever we do,
in this epic we have a list of things we can move to the shared state, and there are plenty of them, like 2 or 3 or 4 components. So I think we can do that before the epic to simplify things.
That's kind of work that we can start without knowing what comes after. Like we just know that it needs to be done, and it will make the work that comes after easier. So
sure.
I had a question or maybe an idea about this map, because it looks like there was a lot of manual effort that went into this. And I mean, this is an amazing map. I'm just thinking, as we get new Sidekiq versions, and as we move things around, like some of this stuff we might start moving to shared state, keeping this map up to date, maybe there's a way that we can auto-generate at least some of it by instrumenting the client library and kind of capturing, a stack trace of where Redis is being called. And so that way we know who, just sort of get some of this information without having to like manually scan through the code and reason about it.
I had the same thing yesterday on that issue that I pinged you on, Igor, and that you pointed me to the logs. The thing, like, we have like instrumentation on the server side for commands, but we don't, at that moment, we don't remember where they come from. Well, we don't know where they come from, and I couldn't find anything that does it from the client side. So that would be really handy to have, like, because then we know when traffic changes, where it changed.
Well, actually, I don't know. Like in theory, we can put some kind of instrumentation into the Redis client, but I'm not sure about the performance and how it would affect our system. So we can give it a try later.
I think we already have some instrumentation that counts calls and so on and dumps it in the logs.
Yeah, well, counting calls is one thing, but looking at stack traces is probably going to add a lot of overhead if you do that on every function call.
Right, but we can sample this very generously and like only look at one call in 10,000 and then just wait 2 days and then we have the data. So the overhead I think is manageable.
Another way to look at this is that this map, again, it's amazing that you made this map, Bogman, but this map shouldn't be necessary. This map is really complicated because of legacy code and just history. But if we clean up this thing, then we can draw boxes with fewer details in them. We could just say Scikit client, Scikit API, Redis Scikit server. We don't care what's inside of them, and there are fewer lines. And then we also don't need to capture the detailed information.
I think what's also challenging about having any map of it is that any map goes out of date really quickly. And even if we have the instrumentation to rebuild it, we have to realize that it's out of date and then rebuild it and then use the information that we find. And I think for now, because we have this, and I think it gives us a path forward as to what we need to do. And I think if we get to the point towards the end of the project that we need to build it again, we should decide if we really need to build the map again. And if we do, we then make the choice of if we're going to do that through instrumentation or do it by hand. But I wouldn't want to be building instrumentation by hand right now because I think we already have the path. But it is good to know that that is something that is possible to do if we decide that this is something that we need to keep up to date regularly.
I guess one of the risks that I see whenever I mean, this is sort of deviating from what Sidekick does natively, right? And may break with some assumptions because we have some stuff that is sort of quote unquote shared and kind of global to the Sidekick system. And then we have some stuff that is sort of per queue or per shard, if you will. And I mean, when a new Sidekick version comes out, we don't know if that behavior changed and we need to kind of revisit some of those assumptions. So I think the long-term view is also an aspect to consider here.
Yeah, agree. So when I investigate the possibility of shading the Sidekick functionally, it is feasible right now, but it's really hard to maintain because it depends a lot on Sidekick internal implementation. So I agree that I lean more to the journal Sidekick cluster when we know what we're doing. I mean, it's feasible. It doesn't mean that we have to do it. It's just like an investigation to compare the solution first.
So then I'll go ahead and create that epic to move some of those interactions out into the shared state. And from what it looks like is a lot of those issues are already created in that epic. So I'll just move those out.
Yeah, we already
to a
have that
separate
epic.
I'll just move it out to do it on its own because it doesn't have to be done as part of zonal clusters. It can just be done as and when to clean this up.
Yeah, what I'm trying to say is that's already in a separate epic inside zonal clusters, so we just need to move that up. We don't need to move. We don't need to create a new epic.
Yeah. Great. If there's nothing further on that one, Bob, you have the next one.
Okay, let me share my screen. It's just something I dropped in real quick because there was nothing on the agenda. And I thought, like, if I have everybody anyway. So I was looking at, I saw some alerts and they were from Thanos. And they were mostly from stuff that I did. So I looked into it a little bit. And these are Rule executions in Thanos that take, no, these are rule executions recordings everywhere. And two that stand out very much are the stage group aggregation and the feature category aggregation in Thanos, not in Prometheus, but in Thanos. Those are taking
Could you just
longer.
scroll up to the expression? Sorry, thanks. Sorry, Bob. I just wanted to understand what the expression that I was looking at.
So the expression says like,
you can carry on.
so how long did the evaluation take? And if that's bigger than the interval, not good. That's what we're looking at here. The red line is the stage group one, the blue line is the feature category one. And that's a bit.
Why is that not good?
Because then we have like if we're trying to run every minute, but if the evaluation takes longer than a minute, then I don't know what Thanos will do, start the new one in parallel or wait, and then we don't have data
I
every
don't
minute.
think you can sum those, by the way. But
I copied this from
I think
the
the
alert.
point still stands. Oh, really? I mean, that's yeah.
Yeah, you shouldn't sum those.
No,
this one
it's
should
not
be
a
static.
it's not a summable thing.
This one should be static. And
I
this
mean, I would just take the aggregation of those and see what the actual values are that you get, and then you can average or something on that. But you can't that's not a valid expression.
Right, because it's the last duration, and this one should be a constant. I don't know what the alert is exactly, though.
I think I understand the spirit of the alert, but the expression is questionable.
Is the expression from the alert?
I added the job to it because I wanted to see if this was also happening in Prometheus. I'm going to have to make this smaller then, I think.
Or start with the table.
Or just do a top K.
I'll start with the table. That's another. And
Does our Thanos support top K at yet or not? Because that's super useful.
Let's add some filters now. What do we have here?
But so going back to what the problem is while Bob is thinking, if somebody else knows the problem is that we're worried that Thanos cannot keep up with evaluating the rules, or
as much as Prometheus as well. But yeah, I think there's a not necessarily Thanos. I mean, these all look like Prometheuses that are actually, well, no, in some cases
no, it's Prometheus and Thanos
as well. Yeah. More worrying to me that Thanos can't keep up, because Thanos should just be aggregating a handful.
Yes, this is what I wanted to bring up. Like the aggregation for feature categories should already be quite small. Like
yeah,
because that's already an aggregation. Yeah, but here are all the feature category. Here's the. Are these all Thanos? Yes, Thanos. Here they are. And env-ops is what is Thanos, I think.
Well, there's instances on there, FQDNs. Doesn't
that
point
just
to
the job equals Thanos? Job equals Thanos would be a good
but I don't want to. I want to see if the same rules also. Is the rule name the same for Prometheus? And
no, they won't be, because the one will be aggregation sets and the other's going to be
so the thing that I'm interested in is if these feature category aggregations take a lot of time in Prometheus as well. So I'm going to look into that like right after. But
251 seconds for talking to a handful of Prometheuses and getting back.
Yes, and these are the
supposedly
stage
a handful
group.
Of
these are the stage group metrics being aggregated into the.
Yeah, that's really bad.
That's and it's really weird because those feature category metrics are just like they aren't that big. I would need to check.
Yeah.
So our
think
concern
we-
is that the way we track these metrics for feature categories, that Thanos can't handle it.
Not necessarily that Thanos can't handle it. I'm wondering why. Like,
I
I'm wondering
suspect
why
that
it's
there's
expensive.
I wonder if there's a thing where one of the Prometheus servers is like not responding and it's kind of timing out, or like not timing out, but one of the backend Prometheus servers is really slow and that's tripping it up, or something like that. It would be interesting to take some of those queries and run them on Thanos and then kind of break them down by the routing
What
labels
part is slow?
and see and see which routing labels are coming back slow, or if it is in fact all of them, which I doubt.
That's the thing that I briefly tried yesterday, and I do query these feature category things often myself. But I always query the global ones. So
yeah, you know that in
So-
Thanos there's like a little pull down at the top that gives you the routing labels, and then you can kind of use those. Yeah.
So I think, I think figuring out whether the issue is in Thanos rule itself or in one of the backing Prometheuses is probably one of the first steps to try and figure out and see if they, like if Thanos rule is just CPU bound or something, then we need to address that directly. But I think we recently reintroduced distributed tracing on Thanos and Prometheus.
Steve mentioned that.
Yeah,
so
and I don't know if
that.
Thanos rule is included in that, but if it is, then that might give you the answer right away.
Yeah.
That'll be super cool if we can, if it's all there.
But if the problem is that, like, my main worry is if it's in Prometheus, because like if
Is that using stack driver tracing? Like, can I go log into stack driver tracing and see magic stuff?
Yes.
Oh, cool. I haven't actually done that yet. Awesome.
Yeah, I think it's on the GitLab Ops project, if I recall correctly.
I don't have anything more on that. Just like if anybody has anything, poke me. Like if you know.
I would say that that's fairly. I mean, because there's also that thing, Bob, where I think I was showing it to you the other day, where loads of the I was showing it to Rachel, where loads of the 6-hour metrics are just points, and then they're not evaluating in between. I wonder if that's related.
It could be.
Because I think that's quite serious.
It could be. I opened another issue for that, but it's just like it's also how you're viewing things. Like if you view things with an overtime function, then there's no 2 points in it. Then something weird happens.
But yeah, so I would definitely do it in Prometheus rather than in Grafana, just because of those things that you're talking about. But then the main thing is whether the series is becoming absent. If you're looking at the instant query, if it's going away and then coming back and then going away, if it's there the whole time, then it's fine. Then it's not it's not updating that often. It's not great. But if it's just then we've got a big problem, because then it wouldn't be alerted.
That's what the metrics that I was looking at. I would need to dig up the issue. But Sean brought it up a bit, building a dashboard. Like on the dashboard, it looks like dots. When you drop that just straight in Thanos without, like it looks like tiny short stripes. But if you remove the overtime function, then everything's just there.
Which overtime is it? Average over or
min overtime in this case.
Oh yeah.
But like if you increase the interval to something bigger than 1 minute, then it's there. And that could be because of the slow rule evaluation, because if we don't have a data point every minute, and it's like, then 1 minute. Yeah, that's the theory. I haven't looked into it. Wait, let me find the issue and drop it in the document.
I'm just looking at the Google Cloud Trace Thanos thing, by the way. It looks, I love this daily histogram of latencies. It's very cool.
You want to share your screen?
Yeah, sure. I haven't looked at this at all, so I'm like, but there's data, and this looks super interesting. Like this presumably is the latency of all requests into this gRPC service. I don't know why I picked that, but I love these sort of histogram over time with not bucketed type things. I find them always really useful, like where the build-ups are happening and everything. Like what's going on there between 60 seconds and 80 seconds. Well, presumably that's milliseconds. Yeah, milliseconds. But this is cool. It's great that we got this. I'm just not quite sure where to find ruler in here, if we can. But nice that it's here. Perhaps we can filter by host name. No, don't know. Oh. It didn't seem to work.
Have you ordered your new computer already?
No, but like I almost can't use Zoom and sharing my screen at the moment. I've got a horrible feeling that my computer is not gonna make the time frame that I need for a new one. But anyway, I'll look at this afterwards. But very cool that it's there. Thanks for that, Igor. It doesn't seem like ruler is in that distributed trace yet. So maybe there's a small change that we can make to get it in, and then we'll have it there forever afterwards as well. And we can solve this problem easily. So as part of your investigation, that might be something, Bob.
I poked Michal and Steve on it, so I'll see what they can do.
Awesome. Cool.
Cool. Is there anything else we're keen to demo today? Great. Well, thank you all for your time. It's been a good chat, and I hope that you have a good rest of your day.
Bye.